Hey, fellow mathers! Welcome to the podcast where math is figureoutable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are amazing human achievements, but they're not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figureoutable. Hey, Kim.
Hi.
Hey, how's it going? Busy. Wait. My life is full of many wonderful things.
It is indeed. Hey, I've got a review for us today, and it's super short.
Okay.
It says, how we teach math has to change. Agreed.
Oh, bam. Yeah.
And it's ethereal lord.
Oh.
And it's simple.
We heard from a lord. Okay.
Yeah, a lord. Oh, you had a lord in one of your
I did.
sessions
Lord Neff,
It's
Sir Neff. That was awesome. I'll never forget that.
So it's simple. Everyone can do more real math than fake math.
Oh,
agreed.
That's a great review.
It's like a good mic drop.
Everyone can do more real math than fake math. Bam.
Yeah. Okay, so speaking of real math and fake math, lots of us grew up with a lot of fake math in middle and high school. But the last few weeks,
elementary too, just to be clear.
That's true, but you now have an affinity for elementary teachers.
It's true.
But in the last few weeks, we've been talking about meaning making and sense making about math in older grades because it can be done.
Bam. And a few weeks ago, I mentioned that we were going to maybe answer, was it Nira's question?
Yeah.
About systems of equations. And we're not there yet, but we're getting there.
We're heading that way.
We are heading that direction. We're actually going to take just a tiny detour today to do a little bit more fun because we can with double open number lines.
Okay.
But I promise next week we are going to hit systems of equations hard. Okay. So what about, Kim? Inequalities. So because we've been having fun with equalities or equations and a double open number line, we thought we'd have a little bit of fun with inequalities this week. If you have not listened to the last two episodes, highly recommend that you listen to at least one of them. That would be behoove you to, it'd be helpful. Okay, Kim.
Yep.
Here is a lovely problem string. First problem. If I said to you that x equals 3, you would be bored because you're like, okay. But today we're going to put on a number line like we have been. So I'm going to draw a long number line, and in the middle of it, I'm putting x on the top of a tick mark and 3 on the bottom of that same tick mark. And I'm saying the x is in the same location as 3. And the question I have for you is, where is 0?
0 is to the left of the 3.
Okay, so I'm going to write 0 to the left of 3. I could put 0x is where that is. I'm also going to ask where the opposite of x is.
On the other side, so -3.
Okay, so on the other side of that.
The opposite of the x.
Of 0, yep. So I've written on the opposite side of 0, the left side of 0, I put -3 on the bottom, and I've put the opposite of x on the top. Cool. So over there on the left, very far left of the number line, I wrote x equal 3 when we started. I'm also going to write that the opposite of x is equal to the opposite of 3 or -3. So we just know both of those things. Cool. What if, new problem, what if x is greater than or equal to 3? So I'm going to draw the same number line, or not the same number line. I'm going to draw a number line underneath it that correlates with the number line above it. I'm going to put, let's see, if x is greater than or equal to 3, what's something you know?
I know that there are numbers that are...
Can we do the equal to first? Sorry. I left it open. Now I'm shutting it down. Do you know x equals 3? If x is greater than or equal to 3?
Yeah.
Okay. So I'm going to start there. I'm going to say, so I know x equals 3. So just like we had above, where we had a tick mark and we had x on the top and 3 on the bottom, I'm going to do that, but I'm going to kind of color that in because we know where I'm going to put a dot on the tick mark. Okay. X equals 3. And then now you can finish your sentence. I'm sorry for interrupting.
So all the numbers that are to the right, all the numbers bigger than 3 would fit what x could be.
In that set? Yeah. So when I wrote x greater than or equal to -3, I'm very quickly going to start saying all the numbers every time I see x. I'm going to say, so I want all the numbers that are greater than or equal to 3. And my number line now has x equal to 3. I have a dot colored in. It's equal to 3. Mm-hmm. And then I've also sort of colored in the number line kind of darker to represent all of the numbers to the right of 3 are also included in that set. Mm-hmm. So I basically have kind of an array where I've started at 3 and I've colored an array going to the right to represent all the numbers that are greater than or equal to 3. Mm-hmm. Yeah? Okay, cool. Do you think I said that enough? Yeah, probably. You're like, well enough, Pam. Stop.
Well, I drew what you're saying, so
okay.
As so you're saying it, I'm picturing it, yeah.
Okay, cool. Hopefully, listeners, you can picture it as well. Staying with this problem, where's the opposite of x? Well, maybe let's throw 0 on there. Can you throw 0 on there? Mm-hmm. Okay, so 0 is kind of what?
To the right of x and 3.
To the right?
I'm sorry, to the left.
To the left?
I'm staring at my paper and it's on the left.
You probably were at 0 and you look to the right. Yeah, okay. So we kind of have 0, and then to the right of that, we have this set where x is equal to 3 or greater than, and it's all colored in. Okay. Where's the opposite of x? Don't go less than or greater than or anything. Just where's the opposite of x?
Don't say negative. Do you want me to tell you what the value of negative x is?
Yes.
Or the opposite of x? Yep. Negative 3.
Okay, so negative x, or the opposite of x, is at negative 3. Mm-hmm. So if we look at where we had kind of drawn the dot, the closed-in dot at x and 3, you're reflecting that over the 0, and you're like, yeah, so the opposite of x now is at negative 3. And we could close in that dot. Mm-hmm. So where I have x greater than or equal to 3 kind of in an equation inequality form, I think we could also say that still that now the opposite of x is equal to negative 3, but we're maybe not done with that relationship, because now we have to reflect all those numbers. You just reflected 3, mm-hmm. but we've got to reflect that whole set. Mm-hmm. So if we reflect that whole set, that ray that we colored in is now reflected over, what is that picture on your?
It's going to be all the numbers going to the left. So I drew a circle on negative x is same location as negative 3. There's a circle on my tick mark, and I drew an arrow going to the left.
An arrow to the left, because it's that whole set. It's all those numbers over there. Mm-hmm. So how do I describe that set with respect to negative x, with respect to the opposite of x? Like if you look at the opposite of x as a thing, and I want to describe all the numbers that are to the left of it.
All the numbers. So it's going to be all the numbers that are less than or equal to
negative 3.
Mm-hmm.
Yeah. Does that make sense? Mm-hmm. So there's a couple things that we know that's true. If we have a set that's where all the numbers x are greater than or equal to 3, we've kind of got that right-hand side. And if that's true, then the opposite of x is going to be less than or equal to negative 3. Mm-hmm. Both of those things would be true. Mm-hmm. Okay, cool. Next problem. Next problem is, what if the opposite of x is equal to, I might change this right here, right now. I am going to. What if the opposite of x is equal to 4?
Okay.
Okay, where's that?
The opposite of x is equal to 4. So I drew a number line, and I put opposite of x in the same location as 4.
Cool. Where's 0?
To the left. So I put 0x and 0 to the left of 4.
Cool. And do you have any idea where x is? Oh, is that what you just said?
Yeah.
Sorry.
I put 0x.
Okay, so how about, we know where the opposite of x is. The opposite of x is at 4. Where's x?
X would be the same distance on the left side of the 0.
So x is that distance of 4, and so that would be at negative 4. Okay, so where I have written negative x equals 4, we could also write x is equal to negative 4. Mm-hmm. And we kind of use that, we're sort of pivoting over the 0 to do that. Mm-hmm. Cool. Next problem. What if the opposite of x is greater than or equal to 4? What are you thinking?
So I put a circle on where I have my number line saying negative x is 4. Okay. That's where they're equal.
That's where they're equal. Okay.
Mm-hmm. And I want the numbers that are greater than 4. So I'm going to the right with my arrow.
Cool. So I'll just describe. Negative x is in the same location as 4, and then we have a ray going to the right. So we've described a set that where we're equal to or greater than the opposite of x. Okay, cool. So if the opposite of x is at 4, just stay with the equal to part here. If the opposite of x is at 4, where's x?
If the opposite of x is 4, didn't we already put x at
-4? We put the not for this problem.
Oh, I have my number line from.
Oh, you're using the one from before?
Yeah, sure. Okay, so negative x is 4, so then x would be -4.
Cool. But now we've got to reflect that whole set. Like we reflected the opposite of x to get x, we reflected 4 to get -4, but now that whole set has to sort of also be reflected. So
I have a circle on x is -4, and I drew going towards the left with my arrow.
And how would you describe that set with reference to x?
It's all the numbers that are greater than -4. Greater than or equal to -4.
Why greater than?
Oh, I lied. Less than or equal to -4.
Less than or equal to -4, because it's all the numbers left to the left of -4.
Yep.
Okay, so looking back at the inequality we started with, we had negative x greater than or equal to 4, and now we've said if that's true, and we reflect everything, then x is going to be less than or equal to -4. Yeah? And I'll just point out, nowhere in here have we done any multiplying and dividing by -1. Nowhere in here have we talked about flipping the inequality sign.
Yes.
We're using relationships and connections to think about, if we know the number, what's the opposite of that number? Oh, we reflect over 0. If we know a set of numbers, what are the opposites of that whole set? Bam, the whole set reflects over. And a thing we didn't do, but we could have, is I could have chosen some numbers, like in the problem we just did where we started with the opposite of x is greater than or equal to 4. And I could have chosen like 10 or, I don't know, 13.5. Anything that was in that first set that we drew that was from 4 all the way to the right.
Yeah.
And I could have said, where is it reflecting? Oh, bam, it's over here. Well, and then to choose another one, where's that reflecting? And if you can see my hand, I've got it open, and then I kind of reflect it left to right. So I can, like, if it's over here, then reflecting it's over here on the other side of 0. So that whole set kind of reflects back and forth. Cool. Next problem. How about if the opposite of x is less than -5?
Okay.
So I've got right in the middle of my number line the opposite of x, and it's in the same location as -5, but I'm putting an open circle there because it's not equal. It's just less than -5. So now when I see that opposite of x, I almost kind of cover it up, and I think all the numbers less than -5. And where is that?
All the numbers less than -5?
Yeah.
I'm drawing an arrow to the left.
To the left. Okay, cool. So if that's true, that there's a set less than -5, and we've drawn it. We've started at -5 with an open circle, and we've colored in all the number line to the left. What is also true about positive x? Because we were just dealing with the opposite of x. What about the opposite of it? Like, what about, what's the relationship happening now? If we have a set where all the numbers less than -5 are to the left of that -5, and that's negative x, where's positive x?
So positive x is going to be 5, and the set is going to be all the numbers that are greater than 5.
And it reflects, bam, over that 0. And so if we know that negative x is less than -5, then x is going to be, how would you describe that set? I've got a picture of it where x is open circle 5, and I've colored into the right. How do you describe that set?
Greater than 5.
Greater than 5. So if negative x is less than -5, then x is also greater than 5. Reasoning about reflecting those sets back and forth and back. Cool.
Yeah.
All right. You want to try one more?
Sure enough. I need more paper. Okay.
I'm almost to the bottom of mine. Okay. First one is 3x, or 3 times x equals -6.
3x is -6. And I'm asking myself questions.
Yeah. What else do you know?
I'm saying to myself that I know x is 2. I don't know that matters, but
x2?
If 3x is 6?
-6.
Oh, then -2.
So maybe throwing 0 in there would be good.
Well, I heard you say 6. That's why I said -6. I mean, 2. So
Okay.
if 3x is -6, then x would be -2.
Okay. Could you tell me where those are on the number line?
I put x is -2 to the right of 3x is -6.
Cool.
And if you want me to put a 0, then I'll put 0 to the right of that.
So a lot of kids will start with 3x and -6, and then they'll think about where 0 is to the right, 6 units. And then they'll go, well, if 3x is there, then sometimes they'll even put 2x is at -4, and 1x is at -2.
But how would they know if 3x is -6? How would they know 2x without thinking about?
Well, they sorry, I didn't mean to say that would be the next thing. So
that's just what they have on their paper.
Yeah.
Gotcha. Okay.
Yeah. So they could have a lot of kind of things on their paper.
Yep. Cool.
But so if 3x is -6, x is also -2.
Mm-hmm.
Good enough for that problem. Next problem. How about if 3x's set of 3x is less than or equal to -6?
I'm going to, 3x is -6. I'm going to color in a circle there. And you said less than or equal to?
Correct.
Okay, so all the numbers to the left of the -6.
So far, that's what we know. We know that we got the set of numbers to the left of -6. Cool.
Mm-hmm. So then I could also... Oh, sorry.
Go ahead. Go.
So then that's 3x is greater than or equal to 6.
You're going to reflect first, okay?
Yeah.
Oh, so hang on. 3x was less than or equal to -6. Are you saying -3x, the opposite of 3x?
Did we say 3x is -6?
3x is less than or equal to -6 is where we start.
Okay, so the -3x is greater than or equal to 6.
And how did you get greater than or equal to? The equal to I'm good on, because you reflected the 3x to the opposite of 3x. You reflected -6 to 6. How do you know it's greater?
Tell me again. 3x, we said 3x was -6.
3x is less than or equal to -6. Yes.
Less than or equal to. So then I reflected to write -3x is 6.
Okay.
But I also reflected the numbers, the set. So what did I say? Did I say something wrong?
No, I just wanted you to say it again.
Oh, 3.
Sorry.
I was like, wait a second. So
good neutral response on my part.
Yeah, it was. 3x is greater than or equal to 6.
-3.
-3x is greater than or equal to 6.
We're audio here, Kim. We got to get this right.
I know. I can't even read my paper. -3x is greater than or equal to 6.
Cool. So
oh my.
So just to keep, this is so audio. I hope you guys are grabbing a paper and a pencil, pen and paper. So on the left, I have 3x less than or equal to -6, and underneath that, I have the opposite of 3x or -3x greater than or equal to 6. On the number line, I've got 2 sets represented. Well, two sets, yeah, kind of. Where I've got 0 in the middle. To the left, I've got a closed circle on 3x and -6, and I've colored to the left of that because it's all those guys less than that. And to the right of 0, I've got the opposite of 3x and 6 in the same location with a closed circle, and the whole set that's been reflected now to the right of that. Nice. All right. Do we have time for one more? I think we do. Let's do one more quickly. Okay.
Paper.
Okay. What if this time we've got the opposite of 3x is less than or equal to -6? Ooh, now I kind of wish I had that. I flipped papers and I wish I was looking at my other one. Maybe. The opposite of 3x is less than or equal to -6. What do you got?
Okay, so I wrote -3x and 6, the same spot.
-6?
I did write that. -3x and -6 are at the same spot.
Well done.
Jeez.
Sorry.
And you said it's all the numbers less than that, less than or equal to?
It's less than or equal to -6.
Okay, so I colored in a circle and I drew my arrow going to the left.
Okay, cool.
All right.
Well, I'd love to know how x relates to numbers if -3x is less than or equal to -6.
Okay, so I'm going to put 0.
Okay.
For funsies. And then I'm also going to, it's to the right.
Of -6. That makes sense.
Yeah.
Okay.
And then, I don't know. I want to play. I don't know what you're actually wanting me to do yet, but I put 3x and 6.
Because you reflected everything. Okay.
So I know that 3x is going to be greater than or equal to 6.
Nice. And I've colored that in, and I've written the equation. 3x is greater than or equal to 6. And I've colored in the 3x and 6 location, and then everything to the right. Okay?
Mm-hmm. Yep.
Nice.
What do you want to know?
X.
Okay.
You've told us 3x, and now I want x.
Okay. So x is going to be where 2 is, but it's equal to 2 or greater than 2. X is greater than or equal to 2.
Nice.
Mm-hmm.
We could have found out the relationship from negative 2x.
Yep.
And that would have been everything less than or equal to negative 2, and then reflected that set.
Wait. You said negative 2x?
I meant
negative x.
Sorry, you're right. Negative x and negative 2.
Yep.
And then reflected that to get the x and the 2.
Yep.
Either way. Nice. Yep. Kim.
Yeah.
Inequalities are figureoutable.
They are, and so not figureoutable for kids if they only get taught flip some things, do some things, but
one other thing I'll mention just really, really fast. There is the move that you could make teachers that if you start off with negative 3x less than or equal to negative 6, where you do the balance thing if you must and add 3x to both sides and add 6 to both sides. And if you do that, you'll end up with 6 less than or equal to 3x. And again, you don't have to worry about this bit about multiplying, dividing by a -1 and flipping the sign or reversing the inequality. By the way, I don't say flip the sign. I say reverse the inequality if you must say it. Mm-hmm. But I don't know that ever should become a thing to do. I think it should always be something that we're reasoning about. Well, yeah, if I reflect this whole set, then I've reflected it, then yes, now the new set is going to be the other relationship because I've reflected over 0. Yeah. Hey, Kim, that was fun. Next week, y'all tune in because we're going to do some systems of equation magic, and you're going to love it. Math magic? Magic math? Yeah, whatever. All right. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.